Hey guys, we are going to continue working on constant rate of change and proportionality. So let's start with some stuff that we already know. And by the way, if you do not have journal notes, on page 195 you can find a lot of this information in the book. So you can either use your hard copy textbook or the online book. Okay, so hopefully remember that a proportional equation is y equals kx. We don't see that on the formula chart. We see k equals y over x, which is that constant ratio. Very, very similar to constant rate of change. So for a proportional equation, remember constant rate of change will always end up being the same as our constant of proportionality. Okay? So if it's linear non-proportional, we use this equation, y equals mx plus b. Okay? And remember, when we do constant rate of change, it's always m, constant rate of change, and sometimes k. Okay? So if it goes through 0, 0, it will also be k. This is our y-intercept. And that is where it crosses the y-axis. Okay? So right here it says the distance of a car travels after t hours can be represented by d equals 65t. D, this is an equation that we definitely want to make sure we know. You might use this in science. Distance equals rate times time. Rate in this case will be speed. So one more time. The distance a car travels after t hours can be represented by d equals 65t, where d is distance, t is time. The table and graph also represent the situation. Let's investigate the relationship between distance and time. So if you look here, if I'm going up, and I know it's hard to see these numbers, this is 130, this is 195. So the difference between 130 and 195, and again if you're on page 195 you can see this better, is 65. Okay? And then from 195 to 260, it goes up by 65. So each time it's increasing, so delta y is 65. Okay? Some of you, on some of your assignments, you're not explaining it this way. I want to make sure that we talk about constant rate of change and 0, 0, or linear and 0, 0. So here, 2 to 3, 2 plus 1 is 3, 3 plus 1 is 4. So it's just showing us how our point changes. So our delta x is 1. Okay? So over here we have it graphed. Now one thing I haven't shown you is that each time here, when we go up and over, like you can tell here, like each time it's 1, well from point to point, this would be up 65 and over 1. Okay? Same thing here, up 65 over 1. If I was counting it on here, it's kind of hard to tell. These are not like exactly on these little points, but you can tell from what these numbers are. But we call that a rise and a run. Our rise is 65. Point to point, it goes up 65. It goes over 1. Okay? Up 65 over 1. So anyway, our constant rate of change, which y'all do know, we've practiced this a lot, is 65 over 1. Now, they graphed 1, 2, 3 points on here, and then they drew a line, and notice it goes through 0, 0. So because it goes through 0, 0, we know this is proportional. Okay? Because it meets two criteria. You have to have two things true. It is proportional because it has a constant rate of change and it goes through 0, 0. That's what I need you to write. Okay? Now, if I was to go backwards to see on my table if it goes through 0, 0, which it will, 130 minus 65 is 65. Take this back 1, and I get 1, because 2 minus 1 is 1. So it looks like you might say, oh, well, it's not proportional. Well, no, we haven't actually hit 0 yet. So we need to go back again. 4, 3, 2, 1, 0. Each time we're subtracting 65, so I get 0. So it does go through 0, 0. Okay? So, our constant ratio, guys, the y, this part right here, y over x, those are just the points, okay? And they all will simplify to the same thing. So what I mean by that is, this is 2 and 130, 2 and 130. So y is 130 over 2. The next one is 3 195. Okay? And the next one is 4 260. Now, if you divide these, like if I divide 130 divided by 2, I'm doing this super fast, you do not have to write this, I get 65. If I divide 195 by 3, I get 65. This is what they mean by a constant ratio, or K, or constant of proportionality. Okay? So, we need 2 reasons to make sure our answer is proportional. Okay? For a table and a graph. Okay? So here it says the constant ratio is, well, we just found that when we divided it, right? 65. So K is 65, okay? So it's also M, but more specifically, it's K. So that means, guys, our equation would be y equals 65x. Y equals kx. Okay, so we found out all that information based on our table, our graph. We have our equation here. And if I wanted to continue, remember, like our table, I could follow my pattern, or I can plug in an x value if I want to. I can choose the x value that I want. So like my next x value would be 5. So I could say 65 times 5, and whatever 65 times 5 is, 30 plus 2, 32. So my next one would be 325. And I bet if you follow this pattern, you're going to get 325. Okay. So, we've already talked about this. We talked about this last week. When 2 variables have a constant ratio, remember that's K, the relationship is called a direct variation. Okay? So remember we said direct variation. Directly varies directly. All it means, guys, is it's proportional. Okay, so when you see that word, you're thinking of this picture. Okay, you can think of this, the constant ratio, but make sure you know it's the picture. Don't let it confuse you. Remember, these are one of those things that you have to be taught to understand. Okay, in direct variation equation, the constant of, should say proportionality, is assigned a special variable K. So if you move on to the next page, it says 2 minutes after a diver enters the water, he has descended 52 feet. Now one thing I noticed when we did the cantaloupe problem is y'all missed that. That is a number right there. Okay, 2 minutes, he descended 52 feet. Okay, the cantaloupe problem, most of you missed that. Okay, so we call that a rate. Okay, 2 numbers, 2 different units. After 5 minutes, he descended 130 feet. And then it says at what rate is he descending? Okay, so we want the unit rate. So our unit rate, we're going to figure this out. It says 52 feet per 2 minutes. So 52 feet, 2 minutes. And guys, just so you know, almost always time is going to be your denominator. Almost always. Okay, so I'm going to divide 52 by 2. 2 into 5, 2. 4, 1. 2 into 12, 6. And nothing left. Okay, so our rate is 26 feet per minute. Now, when you're in 8th grade, they usually just use the word rate. 7th grade, we generally use unit rate when we're talking about per minute. Now, if I divide this other one, 130 by 5, let's just see what we get. 2, 10, 3, pull down a 0, 5 into 30 goes 6 times, 0 left. So we can tell we're moving basically at a constant rate of 26 feet per minute with nothing else, with knowing nothing else. This more than likely is our constant of proportionality, assuming we're starting at the surface of the water. Okay? Okay, so on letter B, it says the distance y traveled in miles by the Chang family in x hours is represented by the equation y equals 55x. Identify the constant of proportionality and explain what it represents. Okay, so it says distance y and then x hours, and again we talked about that, remember? K equals y over x, and we said time is almost always on bottom. Okay, so we're at the constant of proportionality. Well, remember, constant of proportionality is k. Y equals kx, y equals 55x. So guess what my constant of proportionality is? 55. What does that represent? Well, it represents miles per hour. Miles over hours. Okay? Now, let's look at the next one here. It says, pizzas cost $8 each plus a $3 delivery charge. Show the constant rate of change for 1, 2, 3, and 4. Is there a direct variation? Okay? So what they're doing here, and they kind of did our work for us here, they said, well, one pizza, so let's say that we're having this delivered, we have to pay $8 plus $3. So I get $11. Now, if I get 2 pizzas, won't that be 8 plus 8 for the 2 pizzas plus the delivery charge? You only get charged that one time, okay? 8 plus 8 is 16, 17, 18, 19. So that's where we get this. So they're coming up with this themselves. So if I want another pizza, I just add another $8. 8 plus 8 plus 8, 24, 25, 26, 27. Okay, so they came up with our table. And I know I'm talking fast, but I want to get through this. So, constant rate of change, guys, delta y over delta x. How much is it changing by each time? Hopefully you know it's changing by 8, because it's $8 per every one pizza. Please do not put 1 over 8, guys. It's 8 over 1. It's $8 per pizza. So the constant rate of change is 8 over 1. You can just say 8. And then it says, is it proportional? So let's take it back. 4, 3, 2, 1, 0. Each time that I go back, I'm subtracting 8. So what's 11 minus 8? And that would be 3, right? So, is this proportional? No. It does not go through 0, 0. I wish I had time to write that, but I don't. So our equation is actually going to be y equals mx plus b. Y equals 8x plus